Hi, everyone. Good morning, good afternoon, or good evening, depending on where you are at. And welcome to today's webinar, Crops That Nourish, Scaling Up African Breeding Programs for Improved Soils and Health. This is the second webinar in our series following the recent convening organized by CIMMYT with Johns Hopkins University Institute for Planetary Health, which took place in 2024. Today we're exploring frameworks for transdisciplinary plant breeding and seed systems development programs as part of the CIMMYT CGIAR FAO partnership for the Vision for Adapted Crops and Soils movement. We're delighted to have participants joining us from around the world. Please feel free to add any questions or comments in the chat during the presentation, and we will do our best to get to them at the end. Before we dive into our presentations, I'm honored to introduce Daniela Vega, our Acting Executive Secretary, who will share a few words about the partnership and the importance of today's discussion on opportunity crops and soils. Daniela, the floor is yours.
Thank you, Xiomara. Thank you so much. Thank you, everyone. Good morning, afternoon, evening, depending where you are. And welcome again to our Community of Practice webinar. It's wonderful to see many familiar names and some new ones joining us today. I want to start by acknowledging the incredible work that each of you are doing. Having you here today is a true testament that this is more than a program or an initiative. It is a movement that we all believe in. A movement towards more resilient food systems, healthier soils, healthier crops, that can withstand any changing climate. A movement towards opportunity crops and soils. I just want to reinforce that the commitment made by the CIMMYT CGIAR FAO partnership for advancing this vision and opportunity crops for nutrition and soils remains strong and moving forward. This institutional partnership has a 5-year commitment that ensures that our work will continue with the stability and strategic direction it deserves. The Executive Secretariat remains as your central coordination point, ready to support this community's important work. All of you are what make the movement real. Through your research, your fieldwork, your policy advocacy, and your commitment, you are turning this vision into reality across regions and sectors. We recognize that the global context is always evolving, but our technical foundation remains solid. The knowledge we generate collectively transcends cycles and frontiers, and what truly matters, what truly drives impact, is the work that each of you are doing in the field, in the labs, and in communities around the world. So I invite you to stay engaged, continue sharing your insights, nominate yourselves for the next Community of Practice webinar. We want to hear more of the great work that you are doing, and we want to keep advancing this movement on opportunity crops and soils together. This Community of Practice remains as a vital space for knowledge exchange, for networking, for building alliances as we move forward. So thank you so much for your dedication. Thank you for being with us today. And now let's move to today's presentation. I'm really grateful for our speakers today. So Xiomara, back to you for introducing them.
Thank you so much, Daniela, for those insightful remarks about the partnership and the important work being done by all the members from the Community of Practice. Now I'm excited to introduce our presenters for today, who will share their research and experiences from Zimbabwe, South Africa, and Ghana as part of the Opportunity Crops and Soils Initiative. Without further ado, I'd like to invite our first presenter, Dr. Julia Sevilla, to begin. Dr. Sevilla, please go ahead.
Thank you, Xiomara, and thank you, Daniela. Good morning, good afternoon, and good evening, wherever you're joining us from. So as introduced, my name is Julia Sevilla, and I'm the VAX Capacity Project Lead in CIMMYT. VAX Capacity is one of the 4 activities that CIMMYT is implementing, the other 3 being VAX Breeding, Seed Systems, and VAX BT Pigeon P. VAX Capacity in particular, we are looking at trainings or capacity building, if I can say. And here we are aiming to capacitate African breeding programs and research professionals in partnership with both private and public sectors. Specifically, we aim to build a cohort of VAX fellows that will be able to deliver on the VAX vision, which is to foster resilient agri-food systems across Africa, boosting the productivity of opportunity crops improving nutrition through developing and deploying diverse climate resilient cropping systems, and building healthy soils. So we are aiming at expanding the scientific workforce for opportunity crop improvement and upgrading skills of professional plant breeders, as well as strengthening networks of those who will be working on these opportunity crops. So having said that, we will be working with many different institutions in Africa and abroad in a hub and spoke model that we are using. And we have 5 hubs, and the rest of the institutions that will be working with part of our spokes. So as Kiomara mentioned, this webinar is based on the Crops That Nourish workshop that we had in October 2024 in Washington, D.C., which had participants that came from diverse disciplines, geographical and cultural backgrounds, including the types of research they're doing, the experiences, as well as investors were also present. And the overall objective of this workshop was mainly to envision impact pathways for improving soil health and human nutrition, and articulate what support is needed for achieving these gains in Africa. So based on that, we had roundtable discussions which focused mainly on 5 areas, which were crops and seed systems that nourish people, crops that nourish soils, pathways through markets and value chains, as well as pathways for engaging communities in marginal environments and local seed systems, and also pathways for resilient, healthy cropping systems. And so there were a number of questions that we were trying to address. So based on these questions and outcomes of this workshop, CIMMYT VAX capacity, we are trying to orient our capacity building efforts towards approaches that can actually realize some of the ideas that and learnings that were highlighted in the convening. So our January webinar, we addressed several of these key issues by presenting ongoing and planned research with amaranth in Benin and pigeon pea in Kenya. And for this webinar today, Dr. Eva Wilson will summarize what was presented in January. Then she will be followed by today's VAX fellows who will present their ongoing and planned research in Zimbabwe, South Africa, and Ghana. So we have Tinovonga Gonhi from Zimbabwe, Abe Gerano from South Africa, and Mavis Wusu from Ghana, who will be presenting this afternoon. So I'll hand over to Eva to do a summary.
Good afternoon, good morning, evening to every one of you. Yeah, I want to present a quick summary of what we discussed a month ago. We focused our presentations really around the discussions that were held at the first roundtable discussion, focusing on looking at seed systems and integrating plant breeding more closely actually with seed systems work by trying to find out what could actually be good entry points for plant breeders to start work on crops that have maybe had very little improvement, or where most of the knowledge about the crop is actually more with farmers than with researchers because of the little research investments that have been happening. So we looked at questions like, who are actually actors across all these different functions of a seed system? How much are they influenced by the context in the specific countries, agroecologies, social cultural systems? But helping us to look at who depends on whom, and looking at strategies, how to integrate maybe informal and formal kinds of approaches to seed systems and plant breeding development, and especially looking at opportunities to integrate work on diversity. That means crop-specific, intra-crop diversity, multiple varieties, but also crop diversity, and looking at seed system opportunities and options to work across crops or work more for dissemination of diversity as such. the specific talks that Julia just mentioned were focused on pigeon pea in Kenya. And you can see from this slide that the work in Kenya is really involving actors across the whole breeding, seed system, consumption value chains, including communication work, and thus has resulted in a wide range of different outputs and outcomes so far already. And we are hoping in the VAX capacity building to learn from this work in Kenya and try to build up on it and integrate more widely. And I'm not seeing why it's not moving forward. Okay, here you can see some of the outcomes and impacts of the work from Kenya. And we further looked at work on amaranthus primarily and other leafy vegetables in Benin. And what I'm showing here are the experience of the Benin team to really work with a large number of farmers in a participatory approach to identify new varieties that are adapted to specific agroecologies. And here you can see across very different regions in the tiny country of Benin. Just as an example, for really involving farmers more directly in variety identification and seed system development. And the impacts of this kind of work are really far-reaching, mainly to the proactive collaboration of the scientists with the development program in the country, so to really harness capacities across the different sectors. As one good example for integrating across these different seed system functions. I'm sorry I have to rush through these really interesting results, but I want to finish my short overview just by encouraging all of you to take the VAX opportunity crops as an opportunity to actually look at what can change in terms of approaches that you use for your plant breeding work, but also for really looking at systems for variety development and systems for seed dissemination and adoption. And that way looking at the opportunities really for looking at new types of collaborations and partnerships so that we can integrate impacts on nutrition with improved soils, and a healthy planet. And if you're interested to look into more detail, we've listed here some of the publications from the two teams who have presented more details of their results. And I'm sure they'll be very happy also if you reach out to them. Thank you very much.
Okay, thank you very much, Eve. I just want to check if everyone is hearing me.
Yes.
Yes, we can hear you.
Yeah, thank you very much. So my name is Tinovonga Gonhi. I'm based in Zimbabwe. I'm at Marondera University. I'm a research fellow there as a plant breeder under the African Indigenous Vegetables Institute, to be specific. So I'm going to discuss with you about the options for enhancing genetic diversity in farmers' field for our opportunity crops. So as an introduction, I'm not going to talk about what are opportunity crops. We now know them, the crops that have the opportunity to change life in this era of climate change. But what about the diversity? It's just a variation within a population or of a specific species. So how can we enhance genetic diversity for these opportunity crops in farmers' field? So there are many different ways or options or approaches to do this. We can categorize them as scientific, social, political, and technological approaches. So I'm going to talk less of them. There are many, but I'm going to discuss what we are doing here in Zimbabwe at Marondera University and the Zimbabwe at large. First one is accessing diverse germplasm. So connect farmers or researchers with the local and or regional gene banks is one of the options that is very important for us to increase the diversity of opportunity crops to farmers. And here in Zimbabwe, specifically for Marunda University, we are very privileged to have good relationship with the CG centers like ICRISAT and World Veg, where we are accessing their diverse germplasm to make sure that we can improve them and advance and make sure that farmers, they reach, they access these opportunity crops. Also, community seed bank establishment. This is very important because they make farmers have the control over their seed and also they improve their local seed. Here in Zimbabwe, there's an organization that are gurus in this area called Community Technology Development Organization, CTDO. It managed to establish over 21 community seed banks in 12 districts. Why community seed banks? They are very important because they conserve, restore, and vitalize plant genetics. And also it increases the cooperation among farmers and others, is leading to increased seed diversity. The second one is ensuring that quality seed of opportunity crops is available throughout the year, not just being available throughout the year, but at affordable prices. So here, that's where University of Marunda University have made tremendous noise in the market of making sure that African indigenous vegetable seed, especially the Cleomginandra and Amaranth, are available throughout the year at affordable. As you can see, it's just going for $1 a 30-gram seed packet, and that seed packet can cover about 300 square meters. So for a hectare, you need 500, 600 grams. So this option of making that quality seed is available to farmers throughout the year is one of the options that we can increase diversity within farmers' fields. The third one, which we think that is very important there, is utilizing participatory plant breeding approaches, because these opportunity crops, we understand and we appreciate that smallholder farmers, they are the custodians of this opportunity crop that we are talking about. So making sure that we include the farmers along our breeding programs during our selection, it increases the adoption because they feel the ownership of the crops or variety that will be developed and released. So right now, as a Marunda University, we are valuing that and we are embarking on on-farm trials. This is one to your right. This is one of our on-farm trials that is currently in Gutu, Zimbabwe, where we have our finger millet candidate variety, which is showing to be very vigorous, early maturing, as you can see to the right, that the landrace that these farmers used to grow. But to the left, that is our candidate variety that we are advocating to release by end of this year. It is showing to be very vigorous and early maturing, which is one of the crops that we need right now in the climate change era. And we are also engaging farmers to grow amaranth for seed and also for grain for processing. The fourth one, option that we think is very important, which we are doing as Marunda University and Zimbabwe at large, is adopting diversified cropping system. We understand as breeders, mainly we used to do our evaluation of our varieties under soil cropping system. But now, because of climate change, we have to change our breeding objective to do some cropping system adaptation. Is your variety able to fit different cropping system, different intercropping systems? So breeders, we are now encouraged to do what we can call genotype by environment by management. So here in Zimbabwe, there is what is called Pfumvudza scheme, which is spearheaded by our government. Pfumvudza scheme is just an intensive production scheme, a plot where farmers are given a seed, but among the seed, it will be having a cereal, a legume, and an oil seed, so that we increase the basket of the farmer. So with this about conservation agriculture, you can't talk about conservation agriculture in Zimbabwe without talking on our one of the great principal cropping system agronomist of CIMMYT, Dr. Christian, who has done tremendous research on conservation agriculture in Zimbabwe and in Southern Africa at large. The fifth one is utilizing crop wild relatives, land races and exotic, because we understand that in this climate change era, we have to appreciate that a lot of resilient genes that we need to cope to climate change, they are banked in related wild plants. So we have to incorporate. Here in Zimbabwe, we are very privileged. We have a close relative to finger millet called shoboda, which is popular in the southern part of Zimbabwe in Masvingo, which is very adapted to harsh conditions. So researchers and traditional knowledge can maximize on that to improve our local germplasm and making sure that our community, they are resilient to the climatic shocks. Also, we have to introduce new genes from other countries. And as the MUAST or Mandela University, we are privileged that we have introduced the African nightshade varieties and dual purpose amaranth from East Africa through the World Veg gene bank. So these are efforts to make sure that we increase the basket of our farmers, because nightshade, African nightshade in Zimbabwe, it's not available, and also this dual purpose. So these varieties, they are going to be marketed by end of this season. The sixth one is awareness campaigns. We understand that knowledge is very powerful. So we are embarking on awareness campaign as the Marondera University, teaching farmers on the importance of opportunity crops, about their nutrition, about their adaptability, about their culture reservation, because many of these opportunity crops that we are talking about, they have some culture reservation to a certain community. So teaching farmers how to grow them and process them will increase the adoption of these opportunity crops, and also develop business models. For example, right now, we were embarking on a seed outgrower scheme where we are giving farmers seed and all the inputs of Cleome ginandra, amaranth. Then later on, we will buy seed from them. For example, for Cleome ginandra, we are going to buy a kilo of Cleome ginandra seed at $33 a kg. So after that, it means that farmers, they are seeing business out of these opportunity crops. So it means that they are going to take on those opportunity crops. Then last but not least is encouraging local and international seed and food festival along favorable policies. We understand that we have different stakeholders, but it's very important to aggregate those relevant stakeholders to participate in showcasing their product, so that they can share knowledge, they can share even seed. And the moment we're talking now about sharing seed, we are supposed to talk about the policies. And in Zimbabwe, we are very privileged that our government, through the seed services, they are advocating farmers' rights to be very strict, so that farmers, they are encouraged to exchange seed, especially at this food festival. Then for the international festival, we are supposed to have that international seed harmonization policies be in place. Then last but not least, leveraging on the celebrities. Here in Zimbabwe, we are very privileged that our First Lady has embarked on a historical traditional cookout campaign where she is encouraging people or chefs to come and showcase different recipes, especially using our traditional crops, for example, finger millet and marula. So in conclusion, genetic diversity is the hub or power hub that enables the community to be resilient to climatic conditions. And these opportunities, they are traditional, indigenous, and nutrient, but they are always being characterized by being underfunded, be it for research or production in general. And they have a high genetic diversity. However, we have to increase or enhance this genetic diversity using different approaches that I've highlighted, be it scientific, be it social, political, and technological approaches. With this, I want to thank all you all for attending and also listening, and all the partners. I thank you, and I will hand over to my next presenter, Professor Abe. Thank you very much.
Can you see my slide?
Yes, we can.
Okay. Good morning, good afternoon, good evening, everyone, based on your time zone. My name is Abia Gerano. I'm working for the National Agricultural Research Council in South Africa. I'll be giving you a brief presentation on legume diversification and its opportunities for successful breeding program. The slide is not moving. Okay, these are my presentation outlines. So both cowpea and bambara groundnut are nutritious, protein-rich legumes that are widely consumed in South Africa and beyond. They are important food and feed sources, improve nutrition and enhance household incomes and well, sorry for the inconvenience. I think the technology is oh, sorry for that.
That's okay, Ave. We see your slide.
Okay.
It just takes a
Okay.
little bit to update on the screen, but it will change. Thank you.
Okay. Okay, thanks. Okay, so they are important food and feed sources, improve nutrition and enhance household incomes. Oh. Why it's going up and down? Like I didn't touch it.
We're looking at the introduction, and now we change. If you can say next, we can move it from our side, if that's better for you.
It's not going or any.
It might be your network. Apologies. I think it might be your internet, which might take a bit more to change the slides. But if you say next, we will change it from our side.
Abe, we can see your introduction. Can you go ahead and the IT will assist you to move the slides. Seems like he's frozen.
Yeah.
Maybe we can go to Mavis.
Yes, I'm here.
Yes, I think he disconnected. I think it's an internet issue. But yeah, we can move. Eduardo, if you can support us in changing the slides to the end for the next presenter. We apologize for the inconvenience. Please go ahead, Mavis.
Oh, good morning, good afternoon, good evening, wherever you find yourself in the world. I'm Mavis Oseusu. I work with the University of Ghana, the West Africa Center for Crop Improvement. And today my presentation is going to be on the pathways for introducing your crops into tropical production systems. And we're using finger millet as a case study for Ghana. Great. So finger millet is a very resilient and nutritious crop, and it's adaptable to diverse ecological conditions. It's very popularly grown for its grain and forage in the eastern and southern parts of Africa and Asia. Unfortunately, if you look at the map on your left side, you would realize finger millet is mainly in the southern and eastern parts of Africa, whereas the western part is left out. And even though I know there are some trials going on in Nigeria, we haven't really had any feedback on how well it's progressing. Finger millet is, however, a potential crop, and it's increasingly being known for its economic importance and health benefits. It's actually very nutritious and useful for diabetics, so it's advocated for good health. Unfortunately, this map is a model which cannot be utilized for local locations. So for example, it would be very good if I could collaborate with somebody who does models to be able to ascertain which parts of Ghana where finger millet could be successfully grown. And I'm in touch with a few people, hoping I could get some models which are tailored specifically to Ghana to be able to show where exactly in Ghana finger millets can be grown. Currently, it's interesting to know that wheat, which we know as a temperate crop, is being cultivated in Ghana. This initiative started in 2023, and just last month it was launched. So some lines or some genotypes of wheat have been identified to be adaptable to Ghana, and farmers are being advised and advocated to cultivate wheat for Ghana as well. In Ghana, there are 6 agroecologies, and good. All right, so there are 6 agroecologies in Ghana, and looking at the potential for finger millet cultivation, finger millet is known to grow very well in well-drained soils with low to medium or moderate rainfall. And in our savanna and transition zones, where you see the yellow circles, it shows the areas where we find as potential areas for the cultivation of finger millets, because these areas, one, are have well-drained soils, they have the mixed type of soils, and they also have low to moderate rainfall. Their temperatures are also very warm, which is conducive for optimal growth for finger millets. So why would I go for finger millets? As I already mentioned, there are some challenges with growing finger millet in Ghana. The more reason why we don't find them in Western Africa. However, finger millet has a wide range of genotypes, which can be explored to identify adaptable ones to Ghana's environment. There's been a publication on identification of some heat-tolerant lines, which may be very useful for Ghana's finger millet production. Again, Ghana has very dry areas in the northern part where they experience a lot of droughts. They also have very poor soils, and finger millet is known to be very nutrient efficient. They do well in low soil nutrients, and they are also very tolerant to drought and to heat. There are some few which are also known to be saline tolerant. Going back to the map I showed in the previous slide, there's a portion at the coastal side in Ghana where tidal waves cause a lot of flooding. And so some of the farmlands are saline. As you can see in the picture on the left bottom part, those are some identified areas in that part of Ghana where salinity is a problem. And so some of the lands have been abandoned. With the identification of saline tolerant finger millets, for example, we'll be able to utilize these soils for crop production, making land use efficient. Finger millet is also very high in calcium, protein, vitamins, and antioxidants. The more reason why they are very nutritious and have health benefits. So the aim of this project under the VAX program is to establish finger millets as a climate resilient, high yielding, and also nutritious crop for Ghana's food diversification. And it also aims to diversify our cropping systems. How do I plan to go about this approach? I'm going to use a transdisciplinary pathway for finger millet production. So alongside germplasm collection and phenotyping, to identify superior lines, I would also carry out a market survey on new crop acceptance. Because if we are able to find tolerant lines or very superior lines, but then the farmers and consumers are not buying into its production, it makes the work we've done a waste. So this will go hand in hand to ascertain acceptance of new crops into Ghana's crop production. Also, there would be an adaptability trial where the diverse genotypes of finger millets will be grown in the agroecologies I mentioned specifically, and then we'll be able to identify superior lines which are very well adapted to Ghana's environment. And these would be carried on to demonstrational trials where farmers will be involved to be able to help identify and also learn how to grow finger millet, because it's very new in Ghana. It's not been grown in Ghana before. So it will be good to train farmers as well through demonstration of field trials, field schools, to be able to teach them how to grow finger millet the proper way. This would also help with soil rehabilitation, as I already mentioned. If we're able to identify drought-tolerant lines, salinity-tolerant lines, these would be able to grow very well in abundant soils in very poor areas. After the identification of these superior lines, it will be interesting to see how the environment impacts on nutrition. So there will be nutritional profiling to be able to identify if there's been any negative impact on the nutritional quality of the finger millets that have been identified, alongside development of food products. So there are some millets we have in Ghana already, which are incorporated into our foods. However, we do not know how finger millet is used in Ghana, so there will be demonstrations and trials on how well to utilize the finger millets for food production or processing. And this would go along with some engagements with nutritionists to be able to identify how best to utilize these products so consumers would buy into its usage. I already mentioned there'll be farmer trainings for capacity building, where farmers will be trained on the agronomic practices for the production of finger millets. There would also be impact assessment and knowledge dissemination. A lot of knowledge is lacking in the area of finger millets for Ghana. So outcomes of this project will be disseminated both through media and also through publications for people to understand the crop. Stakeholder engagements hold a very vital role in this whole process, because that's the only way to be able to promote adoption of the finger millets and its usage for consumers and farmers. Right. So there are some challenges that I also foresee with this whole project. One main one is the unfavorable germination temperatures for finger millets. So finger millets usually germinate between 8 and 10 degrees Celsius, which aren't temperatures that we experience in Ghana. However, with the vision to identify heat-tolerant lines and also very robust lines, we are hoping to be able to surpass this challenge. There's also the lack of awareness and on agronomic knowledge, and that would also be catered for through the farmer trainings that would be organized and through engagement with stakeholders. The disease susceptibility would also be curtailed with the identification of disease-tolerant lines, like the leaf blast, which is the main disease for finger millets. So if we're able to identify ones that are disease tolerant and are adaptable to Ghana's environment, it will be a great way to solve this problem. And then the very final one is the market accessibility and farmer adoption. As I mentioned, it's quite new to Ghana, so it would be a bit challenging to want to change the taste buds of Ghanaians and to want to introduce something new. It would mean coming up with food products that are very similar to what we already have in Ghana, so it's easier for people to adopt finger millet as part of their food. Right, so what are some of the expected outcomes? I envision that this would impact agriculture tremendously. With the identification of well-adapted finger millets, we'll be able to diversify our food system. Again, it's going to help with food security. So as I mentioned, in the northern part of Ghana, that's where we find most of the poor people within the country. And malnutrition sometimes is a challenge in those areas. With the introduction of finger millets as a nutritious crop, and if farmers are able to grow them effectively, then it's going to be a great source for nutrition and also for economic impact in terms of the farmers themselves and their households. This is also going to be very important for environmental protection, because in cases where we have resilient lines in the era of climate change, it would reduce the use of fertilizers for finger millets being very robust and very nutrient use efficient. We'll be able to grow even in poor soils with limited application of fertilizer. And the biotic tolerant lines or the disease tolerant lines would also reduce the use of insecticides and other chemicals. In conclusion, I would want to say finger millet is indeed a potential crop for Ghana's transformation or agricultural transformation. And in collaboration with key stakeholders like the farmers, consumers, researchers, and other critical policymakers, we'll be able to introduce finger millet successfully into Ghana's cropping system. And scaling up, as I mentioned earlier, is going to really depend on policy support. So the engagements are very important. Engagement with stakeholders are very important for this purpose. And in the future, hopefully, when the tolerant or resilient lines are identified, we hope to also identify some stress-tolerant genes that would promote or progress stress-tolerant breeding, not only for finger millets, but then with the introduction of gene editing and transformation, we'll be able to also transfer these genes to other crops like rice. Thank you all so much for your time.
Thank you so much, Mavis. We're going back to Ave's presentation. Ave, can you hear me?
I hear you. I hear you.
Perfect.
I'm connected.
We will turn off the presentation, and if you can take your camera off, we'll make sure that your connection will be more stable.
Okay. Okay. Sorry for the inconvenience.
No worries.
Okay. So these are my presentation outlines. Next slide. So as I said, cowpea and bambara groundnut are nutritious and protein-rich legumes that are widely grown in tropical and subtropical regions of the country. They improve nutrition and enhance household incomes and agricultural sustainability. They improve soil fertility and soil health because of the capability of fixing atmospheric nitrogen, which reduces also application of chemical fertilizer, and they increase microbial diversity and can be used in crop rotation and intercropping. Next slide. Next slide. So they require relatively low inputs, and the demand for this crop is really increasing in South Africa due to its nutritional composition and some health benefiting factors like phytochemicals and antioxidants. So they play significant role in food and nutritional security. Next slide. So the RC legume breeding program focused on germplasm collection, conservation, and maintenance, agronomic and nutritional profiling, participatory research, and adaptability study, and also breeding for traits of interest and support legume seed system. Next slide. So the farmers in South Africa practice intercropping and crop rotation of legumes with different crops. As you can see on the right side, maize and cowpeas, they practice intercropping of those crops for different purposes. Next slide. So when it comes to cowpea research, we select cowpea for drought tolerance. Different varieties of cowpeas were planted. At the left side, you can see in drought screening glasshouse. So we select drought tolerant cultivars. We do participatory cultivar evaluation and seed production, as you can see on the slide. And also some of the women farmers are selecting cowpea cultivars for leafy vegetable, and also they select immature pods. So they participate in selecting of cultivars for our breeding programs. Next slide. So the outcome for this research is we identified 10 cowpea lines for different traits like yield, nutritional composition, because we mainly focus on iron, zinc, and protein because of malnutrition in the country, and also select for drought tolerance, which those lines are at National Cultivar Registration Pipeline. So we also train more than 1,200 cowpea farmers in seed production, agronomic management practices, and also training on community seed bank, germplasm collection, conservation, and maintenance. Next slide. This is a Bambara ground research as well. So we selected cultivars in our drone drought screening glasshouse. And as I said, South Africa is drought-prone country in sub-Saharan Africa. We took those lines to validate at drought-prone areas to select cultivar lines for our breeding program. You can see our cultivar evaluation trial as a field. Next slide. Next slide. So we have selected 15 Bambara groundnut for different traits, which are now currently under pipelines for national cultivar registration and database. So we identified more than 1,000 Bambara groundnut farmers, and we provide training in different agricultural activities. Next slide. Next slide. So after selecting cultivars, we developed new cultivars using conventional breeding, and currently we are evaluating the progenies at the field for cowpea and Bambara groundnut. Next slide. So our outreach programs and community engagement, we do technology dissemination through farmers field day, publications and presentations. Participatory variety selection is one of the most activity for our breeding program for cowpea and Bambara groundnut, where the farmers select cultivars for our breeding, and also we organize farmers field day. Next slide. We also trained farmers and extension officers. Especially, we also trained the community seed bank farmers how to keep the passport data and conserve the land races for future use. We trained the students, MSc, BSc, PhD, and postdoctoral students. And you can see the pictures where we were providing training for the crops regarding agriculture production technology trainings. Next slide. So conclusion, capacity building of small-scale farmers and extension officers to produce quality seeds of underutilized legume crops, strengthening participatory research with end users to promote these crops, strengthening the community seed gene banks, training and development, and collaboration with national and international partners, including farmers, and strengthening breeding capacity in the institutes. Next slide. Okay, so regarding publication, we have published more than 14 publications on cowpea and Bambara groundnut. you can access the publications on the following links. So we also have collaboration. We collaborated with national universities and also National Department of Agriculture, as you can see on the slide. University of KwaZulu-Natal is our main collaborator in South Africa. Next slide. We also collaborate with the International Institute of Tropical Agriculture and USDA Agriculture Research Service in germplasm sourcing. By this, thank you and sorry for the inconvenience. If you have questions, suggestions, and comments, you are welcome. Thank you.
Thank you, Abe. Thank you very much. If anyone has a question, we do have maybe 5 minutes for questions or comments. You can either drop them on the chat or raise your hand. I don't see any hands up.
I see
Oh,
Dr.
yeah, we do
Sadeke.
have, yeah.
Doc
Yes, Dr. Sadeke and please Enoch then. Hi, Sadeke. Good morning.
you are muted, Doctor. Dr. Sadeke is muted.
Yes, I am unmuting him.
Okay.
If we can be brief, please, so we can, Sadeke or Enoch, please, can you unmute? Yeah, okay, go ahead, Sadeke. Hello, Sadeke. Your microphone is open, you can speak. Okay, we can't hear you, but maybe Enoch, we can go ahead with you.
Enoch has a comment in the chat.
Yeah, go ahead, Enoch.
Okay, thank you very much. Yeah, quite interesting work going around there. My first question to Tino has been answered, but I would just like to have a follow-up question. My concern is if MUAS is buying seed from the farmers, it means probably the funds are coming from a certain project. And if that comes to an end, what then is going to happen? I was thinking of maybe if there's a business model that is self-sustaining, where you have producers producing the seed, and then you have grain producers buying, and then you have processors downstream or consumers downstream, such that there'll be no need for external support. Because the moment the university stops buying, then everything comes down crashing. And then my other question to Dr. Gerano is about the nutritional profiling for cowpea. Is it for the leaves? Is it for the grain? And how then to balance the two? Because in most cases, some of the lines or the varieties that will give you the highest yields will not necessarily give you a good grain yield. So you need to, I think there are some trade-offs there. So how are they managing to deal with that? Thank you.
Can I go ahead or may?
Yes, Abe, please, if you can respond. Yes.
Okay, thank you so much. Thank you. It's a very interesting question. Yes, what we do, we characterize nutritional profiling in the fresh leaves during vegetative growth, and also in immature pods, and also in the seeds. So there are, of course, a variable in the quantity of the nutrients in the different plant parts. Yes, you are right. Some of the genotypes, they have high yield, but when you look at the nutritional composition, you will be surprised with nutrient content. So for our breeding program, we go for good. So high yield and maybe high protein content or high zinc content. So yes, we have a full nutritional profiling in different plant parts on cowpea and also even in Bambara groundnut. We also look at for leafy, because some farmers in South Africa are using the leaves of Bambara groundnut for animal feed. So we are also looking at the nutritional composition in the leaves and also in the grain for food. Thank you.
Thank you, Ave. If anyone wants to respond to Sereke's question, who left it on the chat, it's my general question to all is, how do we mainstream this kind of research? Eva, Julia, Ave.
What is Dr. Sadeke's question?
How do we, it's a more generic question, and how do we mainstream this kind of research? It's not an easy question.
Well, maybe let me just give one kind of answer. I kind of feel like exactly the approach of the VAX capacity building team and program is one of those approaches, is trying to train and involve a wide range of scientists who are already working with these crops to actually learn from each other and widen their experiences to become more actor-oriented, more participatory, and more interdisciplinary in their work and their approaches. So
Thank you, Eva.
I commend the VAX initiative, capacity building initiative, as one of the approaches to do that.
Yeah,
thank you.
Maybe just to add on to that, I think the best would be to develop the whole value chain so that you have it's kind of demand driven. You have people requiring certain products from that very crop, and then there's always constant requests for products, for seed, for inputs that go in there, and information and many other things. So I think as long as the value chains remain underdeveloped, I think it will be challenging, but as they get more prominent and they start driving in a sustainable way, I think even the research will also develop that way. Thank you.
Thank you. And if we do have maybe 1 minute for Dumisani, if you have a short question, please go ahead.
Thanks, colleagues, and good afternoon from South Africa. Well, a very nice presentation from Dr. Gennaro. And I can see that they are doing amazing work as ARC. Maybe my request would be to also partner with the municipalities at the local government in driving the adoption of VAX. I'm sure that would work in for very good cause, because like in eThekwini, we've got the agroecology unit, and we are open to actually look at the partnership, possibilities with ARC in also distributing these seeds to households, because we have noticed that most of the households, they plant your exotic crops. But I'm sure that these households can be also utilized as social enterprises for VAX programs. So, crops. I will actually connect with Abe after this meeting. Thank you.
Thank you, Dumisani.
Thank you so much.
Good, Abby. Thank you to all presenters for sharing their valuable research and experiences. The recording of today's session will be available on the CIMMYT's YouTube channel, along with our previous webinar in this series. On behalf of the FAO and CIMMYT partnership, thank you for your participation today. We look forward to continuing these important discussions on opportunity crops and soils as we work together to build more resilient food systems. For more questions or information, you can reach us also at the PAX Partnership email. Thank you so much and have a good afternoon, good night, or good day wherever you are. Thank you.
Thank you. Bye.
Thank you.
Bye.
Thank you. Bye.
Bye-bye.
Thank you.